Hello, everyone. Welcome back to our series on the essential foundations of mathematics. Before we dive into today's lesson, if you're serious about mastering this and want the complete roadmap I'm following, you can grab the full guide in the link below. While you're there, I've also put together a 100-question arithmetic basics test. It's free to download, so you can test yourself and see where you stand. If you have any feedback or questions, drop them in the comments. I'm looking to improve this for you every day. Now let's get straight back into the lesson. Today, we are focusing on roots and radicals. The primary objective of this lesson is to make square roots and cube roots simple and intuitive. Once you realize that roots are simply the mathematical opposite of powers, the mysterious symbols disappear, leaving only logical arithmetic. Core definition. In professional arithmetic, a root is the inverse operation of an exponent. It essentially asks a backward question. Which specific number, when multiplied by itself a certain number of times, results in the value I see? Square root, represented by the radical symbol. This asks for a number that, when multiplied by itself exactly once, gives the target value. For example, the square root of 16 is 4, because 4 multiplied by 4 equals 16. Cube root, represented by the radical symbol with a small 3, this asks for a number that, when multiplied by itself twice, for a total of 3 factors, gives the target value. For example, the cube root of 27 is 3, because 3 multiplied by 3 multiplied by 3 equals 27. Essential rules. To handle roots with precision, you must understand how they interact with other operations. These rules allow you to break down complex radicals into manageable parts. The product rule. The root of a product is equal to the product of the roots. This means the square root of a times b is the same as the square root of a multiplied by the square root of b. The quotient rule. The root of a division problem can be split. The square root of a divided by b is equivalent to the square root of a divided by the square root of b. The inverse property. Squaring a square root essentially cancels the operation. If you take the square root of a number and then square the result, you return to the original number. Consistency. While square roots are most common, cube roots and higher roots follow these exact same logical patterns. Common errors to avoid. As you develop your proficiency, be careful not to fall into these standard traps. Incorrect addition. Never try to add or subtract roots directly. For instance, the square root of 4 plus the square root of 9 is not the square root of 13. You must evaluate the roots individually first. Confusing roots with squares. Always double-check your direction. Squaring a number increases its magnitude rapidly. Taking a root reduces it back to its source. Ignoring context. In advanced math, remember that negative roots exist, though for this basic foundation, we focus primarily on the positive principal roots. Exercise module. Let's use these diagnostic questions to ensure your understanding is automatic. Pay close attention to these challenges. Question 1. What is the square root of 36? Think. What number times itself is 36? Question 2. Calculate the square root of 64 divided by the square root of 4. Apply the quotient rule or evaluate individually. Question 3. What is the square root of the product of 25 times 16? Apply the product rule for easier calculation. Question 4. What is the cube root of 8? What number used as a factor 3 times equals 8? Question 5. Find the cube root of 125. If you hesitate on any of these, I strongly suggest repeating the core definitions until the answers become instantaneous. Summary. In summary, roots are the inverse of powers. A square root identifies a number multiplied by itself, while a cube root identifies a number multiplied by itself twice more. You can split roots of products and quotients to simplify your work, and squaring a root will always return you to the original value. Weakness here makes later algebra and radicals unnecessarily painful, so ensure this foundation is solid. You've now learned how to reverse the power of exponents by tracking numbers back to their roots. This completes a major cycle in your understanding of how numbers scale. But how do we know which numbers can be broken down in the first place? Why do some numbers divide perfectly while others don't? To answer that, we need to look at the DNA of every number. In our next lesson, factors, multiples, and primes, we will learn how to dismantle any number into its most basic building blocks. Are you ready to see what numbers are really made of?